Thanks, very nice of you. So let's get started. Perhaps you are wondering why I'm starting with this very picture here, with the picture of a scooter. Well, let me elaborate. Sorry? Okay. So what you see here is the high school I attended back then when I was 16. And I still remember we were really looking forward to finally become 16 years old, because here in Austria back then with 16 we have been allowed to drive a tiny moped. And somehow our class was subdivided into groups. The first group was more into traditional mopeds, the second group was more into scooters. And we really discussed a lot what is the best solution. And besides the fact that this whole discussion is ridiculous, this reminds me on one thing. Namely, when doing a decision, it's all about consequences in your very situation. That means there is not a thing like the best or the worst. There is only a good or a bad solution in terms of your very situation. That means you need to evaluate. Thinking back at the situation with mopeds and motorcycles, I think the only consequence is belonging to this or that group. And this in turn reminds me on software architecture, because software architecture is very often about doing decisions, about thinking about advantages and disadvantages of several options in your very situation. And this is especially true for micro frontends. Micro frontends come with a lot of consequences, and not all of them are positive. At the end of the day, micro frontends are about subdividing a huge application into tiny parts. Tiny parts that need to integrate it somehow so that the user thinks they are using one integrated solution, one single page application. But at the end of the day, it's about having several tiny applications that are less complex. And this is what this whole talk is about. In this talk, I want to show you why you should do something like this, why you should subdivide a huge application into tiny parts. And to show you some good reasons for this, I have collected some case studies, some real-world case studies. I interviewed some customers of mine, why they choose for micro frontends. And then in the second part, I want to show you how you can implement micro frontends with quite a modern approach, namely with module federation. But first of all, let me introduce myself. I am Manfred. I am a trainer and consultant for Angular. I am helping a lot of companies with Angular in the enterprise. This is also my focus topic, Angular for enterprise scale applications. And besides this, I'm quite connected with the Angular community. I live in Austria, I do a lot of stuff in Germany, and I'm always happy if I can work together with people around the world. Nowadays, because of the pandemic, this is done via remote technologies most of the times, and this really works well. I was really surprised how well this works. Okay, so let's get started with the first chapter, with the why. Why do companies decide for micro frontends? And for this, as mentioned, I have prepared some real-world case studies. The first case study is from Daedalus Healthcare. They have been called Agfa Healthcare several years ago, and what they are doing is they are producing a hospital information system. You can imagine, in a hospital, you have a huge amount of specialist divisions. You have specialists for X-rays, for operations, and so on and so forth. And somehow you need to bring all those information from those specialist divisions together to one client that is showing everything for a given patient. And that's why they choose for micro frontends. There is one micro frontend for each and every specialist division, and everything is integrated so that they have a common view on the patient. This is one example. Another example is this here. It's a German company. It's called BATEV. DATEV is quite huge. They have 8,000 employees and about 200 products in the area of financial services, accounting, also services for lawyers and so on. And one of the applications is a payroll accountancy. And this payroll accountancy is quite huge. About 80 programmers work on this application. 80 people work on it. And so they decided to split it into tiny parts so that they can work in a more flexible way on this. Of course, at the end of the day, they are integrating everything so that the user thinks that those different parts are part of one integrated single page application. Another case study is from a bank. I'm not allowed to tell the name of the bank because of internal restrictions, but what they are doing is they are rewriting currently their e-banking system. And you know, for us an e-banking system is really a cute thing. There is a dial here telling me that I'm broke, and there is another dial there telling me that I will not get another loan. So really tiny and beautiful. But at the end of the day, behind of all those dials, there is one specialist division with programmers, and they want to do their stuff in isolation. And for us, for the consumer, everything needs to be integrated by the means of different dials. I have another case study. This company decided against Micro Frontends because they told me, hey Manfred, we are just a tiny company. We are just one agile team, 7 developers plus minus. And so using several Micro Frontends would be an overkill. It would be too much for us. The pain would be higher than the gain. And so they really decided against it. But what they are doing is they are organizing their source code in a way so that the source code for one business domain cannot interfere with the source code of another business domain. For this, they are using NX mono repos with access restrictions, telling us that we cannot access all the code within the mono repository. They are separating business domains, so it is a bit like Micro Frontends, but within one monolith. I asked those companies why they decided for Micro Frontends, and all of them told me, well, we have a huge product or perhaps even a product suite, and somehow we need to manage the complexity. That's why we want to cut it into tiny pieces. Also, almost all of them told me it's about scaling teams and domains. They have 60 people or 80 people in their team, and this makes everything a bit more difficult. Coordination becomes too difficult, and so they want to split everything into tiny teams that can work in a very autarkic way. Some people told me it's also about switching out technologies. Perhaps after 5 years, after 10 years, we need to embrace a new technology stack. And then having Micro Frontends, we can migrate step by step, little by little, is for sure a good idea. Or perhaps we are even just adding new Micro Frontends using a new technology stack. And last but not least, one company told me they have repeatedly changing requirements because their software needs to align with the law, and the law is changing all the time. And yeah, they thought when they had a little application or several little applications, adjusting to the law becomes easier. I think this all shows that Micro Frontends are first and foremost about scaling teams. It's about dealing with a huge system where a lot of people have to work on. It is about subdividing a huge group into tiny autarkic teams. If you only have one team, one front-end team with 7 plus minus people, then all of this might be an overkill for you. Then it's very likely that you do not meet the sweet spot of all of this. I also asked those companies how they implemented their Micro Frontends. And some of them used Iframes because of integrating legacy stuff and because of the integration. Most of the companies using iframes started really early, in times where nothing else was possible. Others are using web components that are loaded on demand into the single page application, and those web components hide the framework in question. That means one web component can be built with Angular, another one can be built with React, and so on and so forth. And some of them are just going with hyperlinks, which is a very easy solution, connecting different applications via hyperlinks. However, when following a hyperlink, you are losing all the benefits of single-page applications. You need to load a whole new application. There are several consequences, and not all of them are great. Of course, the great consequence is different teams can work in isolation. However, this also means that most of those companies had quite an effort with building a meter framework. A framework that is loading this micro frontend into the browser window, loading that micro frontend into the browser window, a framework that is showing and hiding different frameworks with respect to the use case the user wants to work on. This is quite a challenge. This is where the 80-20 principle hits you quite hard. The first 80% of this is very simple, but the rest is about dealing with bugs you didn't foresee and so on. People also told me that sharing code at runtime to reduce bundle sizes is difficult. You load a first micro frontend using Angular, you load a second micro frontend using Angular 2, but you don't want to load Angular 2 times, or even 10 times if you have 10 micro frontends. No, this is nothing you want to have. This would increase your bundle size, and increased bundle sizes do not necessarily decrease your startup times. And some people told me it's kind of difficult to achieve a common look and feel across all those individually created microfrontends. Of course, the last point here can be achieved by looking into design systems. Here I will focus on the first two aspects, on the more technical aspects, namely building a meter framework and sharing code at runtime. So please keep those 2 points in mind. I will come back to them in 1 or 2 minutes. Perhaps in 3 or 5 minutes, I'm not that sure. But I will come back to it. Okay, this was the first part. Why did companies decide for this architectural style? And the second part, I want to tell you how to implement microfrontends. And we already saw different approaches, but here I want to show you a quite modern approach, and perhaps even the best approach we have so far, because it can be quite seamlessly. This approach is called module federation. Module federation ships with Webpack 5. You know, Webpack 5 is used everywhere, and so module federation is also available everywhere. And because Webpack has quite high quality standards, so has module federation. The basic idea of module federation is achieving something like this. It is about loading something from a separately compiled microfrontend, from an application deployed over there. It's as simple as using a dynamic import pointing to a different application. And perhaps you are wondering now, hey, why do we need a framework for this? I mean, we already have dynamic imports. So in theory, it should work perfectly without each and every additional solution. Yeah, in theory. In theory, this works perfectly. However, in practice, we have some issues. In practice, all the current bundling solutions do not allow for this. Because all those bundling solutions like Webpack and the Angular CLI using Webpack have one goal, namely squeezing the last bite out of our bundles. And because of this, everything needs to be known at compile time. Everything needs to be there at compile time, even the lazy parts. Everything is compiled together, everything is optimized together. Think on tree shaking, for instance. And then, and only then, everything is cut into chunks for the purpose of lazy loading. But for us, this is too late, because when we talk about micro frontends, we want to load something we did not know at compile time. We did not know at compile time because it has been created, compiled, and deployed by a different team. So to put it in a nutshell, all of this is about runtime integration. And this is solved by module federation. For this, module federation gives us two roles. The first role is the host. In my case, it's the micro frontend shell. And the second role is the remote. In my case, it's the micro frontend itself. Both can be configured by means of the webpack configuration. For instance, you can map URLs here. You could say, hey, the URL mfe1 points over there to a separately compiled micro frontend that is also called mfe1. And here you can say, well, the micro frontend exposes this file with a component, with an Angular module, or just with a function. And when exposing this file, it gets a pretty short name. And now something beautiful happens. I'm sure you will love it. Now all you need is not laugh, perhaps also laugh, but all you need here for this is a dynamic import. A dynamic import using the map names, and so it can point over there and it allows you to grab something from over there. The best of this is Angular itself does not even recognize that you are loading something from a different application. For Angular, this looks like lazy loading. Nothing special in there for Angular. And this is awesome. Because if you remember, one of the negative consequences of dealing with micro frontends was creating a meta framework that orchestrates all those micro frontends in your browser window. Now you don't need this anymore because you can use Angular as is, as it was intended to be used. That means here we get immediately rid of one of those negative consequences. We can put a check under it or strike it through. One little tiny technical aspect, when building a micro frontend, then you can also say that you want to share libraries. You can say, well, here I have Angular, there I have Angular, let's just load Angular once and share it across all the micro frontends. We only want to load it once and share it. Because loading Angular or other libraries 10 times just because of having 10 micro frontends does not make sense at all. And this is really as easy as this. Just register the name of your library to share in your configuration and box your Anki. And this resolves the second issue I've presented you before. The second issue companies told me about, namely sharing libraries have been difficult in former days. Nowadays, with this, it is a piece of cake. Of course, you want to use it with Angular, and to use it with Angular, you need a little tiny CLI plugin. I've written such a plugin. You could also write it by hand. It contains some schematics and a custom builder, but you can also load it via npm. In my case, you can ng-edit. Then you can adjust the generated webpack configuration, and then you can ng-serve everything, and you will see that everything works or nothing works, depending upon how well you structured and modified your generated configuration. It's really as easy as that. You only need this little tiny plugin to enable module federation in Webpack. Webpack comes with the CLI, but it needs to be enabled. Okay, I know all of this is a bit abstract, and that's why I've prepared a little tiny demonstration for this. I'm always saying all of this is a bit like the 1980s. You know, you need to experience them in order to know what they are about. And so let's have a look into such an experience, into a demonstration. In this demonstration, I have a shell, a micro frontend shell, and here I have a micro frontend. It has those dashed red borders. And when clicking here, you see this separately compiled and separately deployed micro frontend is loaded into the middle of my shell. However, we really talk about separately compiled and deployed stuff. To prove this, I'm using different boards here, board 5000 here and board 3000 there. And no, this is not the prerequisite, but in my opinion, this really proves that we are loading something that has been separately compiled and deployed. Let's restart this. Let's have a look at the network tab when loading flights. And here you see from Angular's perspective, also from the user's perspective, this really looks like lazy loading. A chunk is loaded, however, the chunk comes from a different origin, localhost 3000. And if we look at the bundle sizes, here we have 10Ks in debug mode. This is quite small. And this proves that Angular itself is shared. Otherwise, this bundle would be far huger. It would have more than 100 Ks. So I really think that proves that we are sharing stuff. So let's have a look into the source code of this. In my very case, I'm going with a monorepo. This is not the prerequisite. You can totally go with different repositories. Here I have a monorepo. And this monorepo consists of two traditional Angular applications, my micro frontend and my shell. There is nothing special about those applications. Nothing special, but there is this webpack configuration. It is generated by the plugin we've talked about before. And you don't need to worry, it is only a partial webpack configuration. You see it here, 2 or 3 screens when I'm using this big font size. So it's just a partial configuration, the rest is generated by the CLI. And when looking here, the most important part is configuring the module federation plugin. You need to assign a unique name to your micro frontend. You need to define a file name where module federation puts some metadata into. We need some metadata about the micro frontends in order to load them on demand. And this is the most important aspect. We can expose files. Here, for instance, I exposed an Angular module. A traditional Angular module, if we look into this, just an Angular module with some child roots. That means when we load this into the shell, we can immediately jump to one of those child roots. We can jump into the middle of this microfront. Yeah, and besides this, I'm sharing code. Angular core, Angular common, and so on. I don't want to load it several times. I only want to load it once. This is everything we need for the micro frontend. Traditional Angular application plus this file. And if we look into the shell, we see a similar situation. Traditional Angular application plus a generated webpack config. Here we can map URLs. I can say, hey, the URL mfe1 points over there to a different micro frontend, and over there it's also called mfe1. And by the way, here we have the metadata. The metadata we need to know in order to interact with it. You remember, this metadata is generated by Webpack. When we build the micro frontend, this metadata file is built too. Of course, this is kind of static, because I need to hard code the location of the metadata, also the names of the micro frontends within my Webpack configuration. I cannot change this at runtime, but I've got you covered. There is an alternative that allows you to go with dynamic stuff. In this case, you don't need to configure this upfront. Instead, you can just define those metadata at runtime. You can tell Module Federation, hey, Module Federation, I have a micro frontend. It's called this way, and here you'll find the metadata. But for the sake of simplicity, let's get started with this static approach. And besides this, we can also share stuff here. I also list my shared libraries. And that's it. Now everything I need in order to load the module from the micro frontend is a lazy load. A traditional lazy route. It looks like this here. Path, load children, import, and import points to the map names. That's all. However, if you want to go dynamic, if you don't want to know all this stuff upfront, like the names of the micro frontends, the numbers of the micro frontends, and the locations of their metadata, you can comment this out. And then here you can switch to a helper function that is telling Module Federation at runtime that we want to dynamically load something we did not know before. This helper function is called load remote module in my case. And here we can point to the key data, like, let me grab this location here. Remote name, and the exposed module. And that's it. And of course, here we are just talking about strings. That means those strings can come from everywhere. You can load them from a configuration file or from a service telling you, well, today, please use this micro frontend, and tomorrow, use those two additional micro frontends. You can even create routes in a dynamic way. Okay. Let me come to a conclusion. I think we've seen there is no free lunch. When we talk about micro frontends, there are several consequences, because at the end of the day, we turn compile time dependencies into runtime dependencies. Everything is just integrated on runtime, and during runtime, several things can go wrong. So it's for sure a bit more difficult. And that's why this is just a thing for splitting huge teams into tinier teams. It's about scaling teams over different business domains. And we have seen that Module Federation is really the missing link here, because if we need this, it makes everything drop dead easy. We don't need a meta framework. We can use Angular as is, as it was intended to be used, and we can share libraries. It's really straightforward. And there is one last thing I really want you to remember, namely, please remember the story with the motorcycles, with the mopeds and the scooters. Because it clearly shows that there is not a thing like the best solution. There is always a more or a less fitting solution for your current issue. You always need to evaluate different candidates, different possible solutions for your very situation. I think this is what life is about, and of course this is also what all software architecture is about. So please keep this in mind. Okay, so thanks for having me. Here you'll find my contact data, and I've already uploaded my slides to my blog. If you want, follow me on Twitter to stay in contact. And